Hello everyone, I'm Rong Gu from Nanjing University. It is a very honored to give the talk on the Data Orchestration Summit 2020. I'm a founding PMC member and a maintainer of Alluxio Open Source project. Currently, I'm an associate researcher at the Department of Computer Science of Nanjing University, China. I'm also the author of one book on Alluxio, and have published over 20 papers in the peer-reviewed frontier journals and conferences. Previously, I have worked in R&D of big data system at Microsoft Research Asia, Intel, and Baidu. I started to contribute to Alluxio Open Source project when I'm a PhD student. Since then, I made a contribution to the optimization of the Alluxio project's caching strategy, performance evaluation, and so on. Today, Yang Che from Alibaba Cloud and I will bring you a joint talk about a new open source project in the cloud-native area. It is built over Alluxio. So I will show you the slides. As you can see, the name of the project is Fluid. It connects Alluxio and Kubernetes. So, what is this talk about? Basically, we will discuss the data and application of orchestration in Kubernetes. Kubernetes can orchestrate the applications over it very well. However, for those data-intensive applications, one should also consider how to orchestrate the data and applications together in an operational way to achieve good performance. In case some of you are not well familiar with Kubernetes, I will talk a bit about the Kubernetes. Talk a bit about it first. Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications, such as Docker applications. It is widely used in many cloud scheduling systems, and nowadays even becomes the cornerstone of many cloud-native applications. Kubernetes has attracted so many deployments for quite a lot of its advantages. We can name some key advantages here. First, it provides users with out-of-box management, including self-healing, auto-scaling, security, logging, monitoring, and so on. These features save quite a lot of time for the developers and operators. Second, its property inherited from Docker, which bring better isolation for performance and security. Third, Kubernetes has a rich ecosystem and a large open source community now. It means that you have little risk about using an unmaintained project in your infrastructure layer. Fourth, it supports heterogeneous deployment in different clouds. This is very important as many applications are deployed on the cloud nowadays. And the cloud infrastructure market is very diversified, including many public cloud providers such as AWS, Google Cloud, Microsoft Azure, and Alibaba. Besides the public cloud, there also exist hybrid cloud, multi-cloud environments. So this is very important. The big data and AI applications have become more and more today. They have driven the big data and AI tools or software become sharp and mature. As we mentioned above, Kubernetes provides easy to deploy, easy to maintain, elastic, and low-cost abilities. There is a trend that more and more data-driven applications, such as big data and AI applications, runs on Kubernetes now. However, almost all the data-intensive applications run on Kubernetes face a challenge. That is, the data accessing in Kubernetes from them is very slow. We can see from the left bottom figure. When moved to cloud, even use cloud SSD, the training speed of the ResNet 50 drops drops 2/3. It is many because of three reasons. First, the GPU requires high I/O throughput and low latency. Second, the separation of computing and storage causes I/O latency. Third, single machine cache can hardly meet the massive data acceleration requests. So, this reminds us about Alluxio. Alluxio is an excellent distributed data orchestration layer used in the environment that enables separation of storage and computation. It brings speed and agility to big data and AI workloads, and to reduce the cost by eliminating data duplication. So, we think that if we can bring Alluxio in Kubernetes environment in an appropriate way, we can bring good training performance, good scalability, and low cost for users. Alluxio can provide a good cache storage there in Kubernetes. And cache is important, but there still exists many challenges. First, the resource pooling causes cache invalidation, and this should require some probability. Second, Kubernetes scheduler is not aware of cache locality. Third, cache capabilities should be also scalable, because the applications are very scalable upon it. So that's why we build Fluid. The key point of Fluid is that it does not mean if you use the cache, you can just get the data acceleration. If you want to get data acceleration in Kubernetes, you should manage the cache and manage the applications when consume cache in the system way, especially in a dynamic environment like Kubernetes here. So Fluid provides best Alluxio data orchestration experience in Kubernetes. Let me talk a bit about the benefit of Alluxio plus Fluid. First, Alluxio will be responsible for data orchestration and management, such as load metadata, load data, and handling caching, and handle caching. Fluid will deploy the Alluxio components in Kubernetes and auto-scale it on demand. Fluid is responsible for scaling data-driven job with data locality knowledge. Fluid also can automate some user-facing operations, such as prefetch the data, scale out or scale in the cacheabilities, and set the number of the data replication. Finally, Fluid makes cache access from Kubernetes transparent. That's the first part of this talk, and then the next part is about the architecture and the demo of Fluid. Yang from Alibaba Cloud will introduce it. It is very vivid in fact. Don't miss it. Thanks, guys.
Hi, I'm Yang. I'm from Alibaba Cloud. I'm working in the container service team and focus on Kubernetes development. I'm also very interested in building elastic machine learning platform with cloud-native technology. I think open source is changing the world, so I'm very active in open source community. I'm the author of GPU Share Scheduler, which has more than 15 production users. I'm the PMC of Alluxio community and promote the collaboration between Alluxio and Kubernetes. I also have a lot of contributions to open source communities like Kubernetes, Docker, and Kubeflow. Now, my focus is building elastic data orchestration on Kubernetes. It's my honor to attend Data Orchestration Summit, and thanks to Alluxio, we can discuss the future of the data orchestration technology. Today, Rong and I will present the open source Fluid. Thanks for listening and welcome to feedback. Now, let me introduce the architecture of Fluid from top to bottom. First, the user needs to define two custom resources. One is dataset, another is runtime. The relationship between dataset and runtime is one-on-one. And inside the Fluid operator, there are two major components. The one on the left is the Fluid Controller Manager. It's responsible for scheduling the dataset. In Fluid, we convert the scheduling problems of the dataset into the scheduling problem of the data acceleration engine. The Fluid operator contains three components. The first is dataset controller. It manages the lifecycle of the dataset, including creation, binding, unbinding with runtime and deletion. The second one is runtime controller. It manages the lifecycle of the runtime, including creation, scale out, scale in, cache prefetch, and cleanup. The Alluxio runtime is the one of the implementation. The third one is volume controller. It's responsible for creation and deletion the data volumes related to the dataset. On the right is the application scheduler. It's responsible for assigning the pods or jobs to the appropriate node with the information of the cache. There are two components. First is cache collocating plugin. It schedules the job of pods to the cache node intelligently. No need the user to specify it. Second is the prefetch plugin. During the scheduling time, the scheduler can notify the runtime to prefetch the data to the specified node, which the job will run on it. Now, let's see how to use Fluid. First, the admin creates the datasets. In this sample, the dataset has two data sources. The first one is object storage service. Another is the persistent volume claim in Kubernetes. And the Fluid will provision the Alluxio runtime to handle this and create persistent volume and persistent volume claim for it. And the data scientist just creates a job or pod that uses the volume with the same name of the dataset. Then the data scientist can enjoy the distributed data acceleration without of being aware of that. When the dataset is ready, you are able to check the total size of the dataset and the cache capability the runtime can provide. Then you can determine if you need to scale out on this information. And with this status, you can also analyze why you get poor data acceleration and how to improve it. And when you run the same training job several times, some of the data is already cached into some node. But the user is not aware of that. When you use Fluid Scheduler will make it transparent to end user, but get a very good result on it. The procedure is that the user creates a job or pod with the PVC name, which refers to the dataset name. Then the Kubernetes scheduler finds the cached node in the step 2 It will filter out the nodes which doesn't have cache engine on it. And in the third step, it will prioritize the order of the node list according to which node has the most cached data. In the end, it placed the job or pod to the appropriate node. We have several demos here, and we also put these demos on our GitHub for your reference. And I will show you demo 3, how to accelerate persistent volume in Kubernetes. As you know, persistent volume is widely used in Kubernetes and is a native way to access remote storage in Kubernetes. When there are many clients accessing the storage service at the same time, the bandwidth of the storage service is becoming the bottleneck. We have found the training job is quite slow on using remote storage in such situation. How to accelerate training speed without any big modification? Let's see demo 3. In this demo, we are focusing on 3 points. First, how to use. Second, compare the training speed. Third, compare the time cost. Okay, let's start. We run this demo in NFS PVC first. Create PVC on NFS. Okay, let's see the PVC and PV are ready. Now submit a job. Use the PVC directly. Okay, let's check the training speed of NFS. It's about 600 images per second. The time of training is about more than 1 hour. Now let's move to Float. We can see the way to use Float. Just check the mount point. Okay, the dataset is set up. And the related PV and PVC is also set up. The data scientist the training job again with Float. A very little change, just the persistent volume claim name is changed. Okay, let's see the current training speed. It's about 1600 images per second. It's much faster. Now the job is complete. Okay, and the cache is fully in the Kubernetes. In the end, let's compare the result. We can see there are a big in speed and training time. In the summary, we can two benefits in this demo. First, a very good acceleration result, about 2 times improvement. Second, very easy to use, no matter to admin, no change to existing infrastructure. Because build some Alluxio configuration optimization inside Fluid, we can reach a very exciting benchmark result. But due to the time limitation, we don't spend too much time to explain the figure. In the next session, Unisound will present their result in production environment. They don't do any further optimization based on Fluid. If you'd like to know more about the Fluid, welcome to our GitHub repo and project homepage. Okay, in the end, thanks very much for your watching, and your feedback is very welcome for us. Okay, thank you, bye.